Hello everyone and welcome. My name is Eric Coleman with IIST and I'll be the moderator for today's webinar, Preventing, Detecting, and Testing Away Defects for Agile and Non-Agile Environments by Michael Ma, Managing Partner of QSM Associates Incorporated. We're excited you're able to join us today. Set aside an hour to attend this webinar. This webinar is sponsored by IIST, the leaders in education-based certifications and training. For more information on how IIST can help you or your organization, please visit testinginstitute.com. This webinar is one of a series of free webinars offered by IIST. Be sure to join us for the next webinar in the series, Gaining Control of Product Releases with Integrated ALM by Dr. Meg Dehanna on November 17th from 11 a.m. to 12 p.m. Central Standard Time. To learn more about this and other webinars in the series, go to testinginstitute.com. You may submit your questions at any time by using your question box in your GoToWebinar window. Today's presenter will answer as many questions within the time allowed at the end of today's session. This webinar is being recorded and will be made available for viewing within 48 hours at testinginstitute.com. At the end of today's webinar, you'll be asked to complete a short survey. At IIST, we strive to provide the highest quality educational resources for the public and would appreciate it if you could take a few minutes to complete this short survey. I will now turn the webinar over to today's presenter, Michael Ma. Michael?
Great. Thank you very much, Eric, and welcome everybody. It's a pleasure to meet with you this morning. I'm excited to share some really insightful case study data that I've had the privilege of gathering in my work and research in the software industry, and some of what you're going to see has actually been featured in past keynote addresses at IIST conferences like the PSQT conference. And then some new stuff. So this is all quite exciting. We're going to get to be a fly on the wall and look at what we're seeing from data on detecting and testing away defects. So my lens is from the standpoint of a researcher involved in what's called the benchmarking practice at a think tank outside of Boston called the Cutter Consortium. And as a managing partner for more than 25 years with a company called Quantitative Software Management, or QSM Associates, I've worked with clients on looking at quality statistics and productivity patterns that are in their data, which right now in our worldwide global database, there's about 12 to 1,300 completed projects. So you're going to be seeing statistics that are unprecedented in terms of the volume and the depth of what we've been collecting. So with that, talk a little bit about the database. Obviously going back many years, it includes many different dimensions of software development. So not only Waterfall, not only Agile, not only in-house, but also offshore and outsourced, new development as well as major releases. And in that library of statistics, we've actually created trends that you can see in terms of productivity and defect statistics on the desktop. And from that research, we've also created modeling technology that can do predictive forecasting. And that's one of the topics that I'm excited to share about when we first discovered breakthroughs of looking at defect patterns and mathematical curve fits to predict the future from defect patterns. That was a great breakthrough in our research. We've spoken about this, like I've said before, at conferences around the world, not only conferences in the United States, but also in Europe, and Germany, and the Far East. And a lot of folks are very fascinated in seeing what's going on at different areas around the globe. So from time to time, we've also done industry benchmark studies in different countries. So let's go ahead and talk about how I got into this. I didn't listen to my father, who was a banker on Wall Street, back when some say it used to be an honorable profession. No, I was fascinated with the Apollo space program, and in one of my early career positions, I wound up on the Triad II nuclear submarine program. So this huge 2-football field long vessel had a very sophisticated state-of-the-art navigation system which would fly a vessel this large under the ocean around undersea mountains and canyons. And at a rather young age, I was put in charge of QA for the navigation subsystem, which was, talk about fly-by instruments, a very complex control panel. So think of Captain Kirk, Scotty, and Sulu at the helm, steering something with no windows, and it was all done with very sophisticated code. Now I'll talk a little bit about our target for building defect-free code, because as you can imagine, if you have a bug in the software that results in a navigation error and sends a submarine in the wrong direction headed toward an undersea mountain, that's a really bad thing. So what we wanted to do was dramatically shrink what's known as the Rayleigh defect or bug curve. That research even outside of QSM and inside of QSM showed a pattern of bugs building up to a certain peak and then having a long tail. So it's named after a British mathematician by the name of Rayleigh. And we found that we were able to observe what influenced this curve and made it get big and ugly and long, which could be a problem, or what made it shrink. And as QA professionals, looking towards the latter, say, 30% of this curve, oftentimes that's when we get the handoff and we've got to test out the bugs. So starting at about, say, 2/3 of the way to the right, our task is either very, very straightforward and remarkably easy if the peak of that curve is low and tapering down quickly, or it's very, very ugly and painful if that curve continues to explode up with bugs in the code. Meanwhile, as you probably already know as a QA professional, on the right side of that graph is the deadline. And if that bug curve grows and we can't get it down through our testing and remediation, then that's like the walls closing in the movie Indiana Jones and the Temple of Doom. So we've got to think about what actually causes that curve, as well as when we're in the middle in flight on that curve, what can we do about detecting defects and then testing them out and delivering clean code on time. Now today, instead of flying a nuclear submarine, I tend to fly things like this. This is a Piper Super Cub on floats. I just took this last week. Happened to be in the Pacific Northwest, around the Seattle area. This is a quite different control panel for navigation. No software, where co-pilot and I would fly this on the water, not under the water. I bring this up because throughout the talk I'm going to be talking about navigation analogies, because it's near and dear to my heart, and how we can navigate through our releases as QA professionals and be the best at what we do about finding and fixing bugs. So let's talk about the big picture about the Triad. What can we do about strategies that would create the environment where defects are prevented in the first place? Because if they don't work their way into the code, then we don't have to worry about getting them out. If they do get into the code, how do we best find the presence of defects or bugs in the code so that we could pull them out and make sure that through testing and remediation we get that defect curve down and we therefore make our dates. So that's the three areas that we're going to be talking about in this webinar. And let's start off with bugs on how not to do it. So what's a bad scenario? This happens to be a sketch. Hopefully you can read my scribble of my handwriting, of a client that had a very difficult, painful scenario when it came to an explosion of defects. It happened to be an electronic medical records project. The company was in Raleigh, North Carolina, and they were responsible for the concept design phase in the blue on the left between March and July, as well as the requirements and definition phase, which is in the green, July through October. And then the build phase was in the red, starting at about 7 people on the team, bumping up to 30, and this very ambitious peak of 95 people at the peak. Now you'll notice something a little bit interesting about this graph if you see what I saw, because to me, the alerts started firing off in my head about bugs. So once I saw this, I had like a PTSD moment, and I said, oh my God, the test team on this project is going to suffer terribly. And when I said that to the senior vice president, he said, well, why would you say that? And I said, well, it seems to me that as you've described the deadlines being very ambitious, I'm looking at the steepness of the acceleration of your headcount starting in the July-August timeframe, and within 4 months, 5 months, going up to almost 100 people. And he said, well, why is that a problem? We need to get the work done. I said, the reason that's a problem is because when I look at patterns from our database on the average staffing for a project of this release, it's not 95 people. It's more like 40 at most on the upper edge of what we see in our QSM database. And he said, well, why is going up to 95 a problem? And I said, well, first, we know from the research and from the data and other people's published papers that communication theory reveals to us as we double an aggressive headcount, our defects don't double. In fact, they go up in a nonlinear and a geometric way. So if you're thinking of, say, a team of 4 people, for an example, the number of communication paths are the 4 sides of the square and the 2 diagonals. There are 6 possible communication paths for a design team to communicate with one another to get the design right and build the code. When you double the 8 and you have an octagon of 8 dots, you have all of the 8 sides of the octagon as communication paths, but then all the diagonals, guess what? They total 24. So 6 communication paths with a team of 4, 24 communication paths with a team of 8. You've got a factor of 4, a 4 times increase in the number of communication paths. And guess what? When you double staff, your communication paths go up by at least 4, if not more, and the defects go in the same step. So my worry is that a project that has got this kind of staff acceleration is going to be driving defects into your code, and now look at what happens after January. And he said, well, why is that a problem? And I said, your team is ramping down on testing as you go from system test to beta, which, by the way, system test after 4 months, that seems very strange to me. But when you're at the point where you may have over 1,000 bugs in your code, you're ramping down in headcount in your test team. Why would you do that? And he said, well, we need to ramp up for the next release. And I said, okay, this is going to be a problem because if you have, say, 1,000 defects in the code and they miss them in testing, guess where they'll be? And he said, technical debt? I said, exactly. You're going to leave those bugs in the code, and you're either going to have to fix them later or you're going to be scrambling like crazy. So if you have any inkling as a QA professional that you're seeing anything like this, heads up, hold that thought, because you may have a little bit of an early warning of what could happen when the code drops get to you. Now here's another case of a way of how to do it. This happens to be a credit card company. The code developers were working on something called mobile encrypted swipe, a combination of test and QA and developers working only at a peak headcount in a more agile fashion, going from 4 to 8 in the build phase and running out to May in a series of sprints. Now, when we collect data that winds up in our database, we often start with a sketch like this, where we'll look at, say, the story phase in green and the build and test phase in red, and we capture the time for each of the phases and the effort. And this was a way to build software that had really clean code. And when you look underneath where it says January 2013, the bugs totaled only 61 bugs in the code, which was easily remediated by their test team because they were looking at building a smaller release, just-in-time delivery, and also managing the scope and managing the headcount so they could get high-quality code. So this is an example of how to deal in a more effective manner to prevent the environment that's going to drive your bugs way up. And it really comes down to how do we deal with speed. Because in response to schedule pressure, which QA is going to be staring at when the deadline looms, a lot of times what we find is a temptation by some companies to do something that creates what we call optional chaos. When we severely compress a project by either one of two ways, we might, say trying to cram in too much scope in too short of a time. We might wind up having a reflex reaction of throwing anybody we can grab on it, or multitask as much as we can because another project's in trouble and they need our help from to that team from another team. We create a level of chaos that works its way right into the code. And that's where QA then suffers. So that's what not to do, and there are things of what to do. And let's look at the implications of if we do it right by setting the stage up front. You may not have any influence on this, but you can have some say in it, or you may also recognize if it's happening to you. So talking about a company that did it right, this happens to be a client in the Midwest that I've been working with that went with pair programming. I didn't mention this on the nuclear submarine program, but when we wanted to minimize defects in the code, we actually worked in pairs on a waterfall project. So it happened to even be to a Department of Defense mil standard software lifecycle, which if you looked at it, it would look quite waterfall. But there are a couple of things that we did that were ahead of its time. I'd say it was before even the word Agile came out. So we co-located all of our folks in one large room, like this company. We had people who were the best that we could have, that we could retain or hire. Many of the folks were PhDs and master's level scientists. We also had them working only on one thing. We didn't split them to do 4 projects at once. And we had people working in pairs, which seemed odd at the time, but it was something that we felt would give immediate code review, immediate requirements review, immediate backup, which seems counterintuitive that you'd be paying double the amount to build a certain block of code. But when you're talking about building code clean in the first place, we proved that it worked over 25 years ago on a nuclear submarine program. That Triad and 2 nuclear submarine navigation code is still in operation today, more than 25, 30 years since it was actually written. So this particular organization also went with what they called drinking the Kent Beck Kool-Aid, because Kent Beck said, if we're doing things right, we should see it in the QA phase where defects are dramatically lower and our throughput should be higher. So we should be seeing higher productivity and we should be seeing fewer defects. And when I show you this slide, this is a Trendline slide where 5, 6 releases of this company are plotted against the QSM industry trend line, where the center trend is the number of defects found and fixed during testing for smaller projects on the left, medium-sized projects on the middle, and larger projects on the right. And we found that their defect levels across 6 different releases were consistently below that center solid line, which is the industry average. The ranges of the bell curve on that industry average are the dotted lines above and below. And as projects started moving towards the larger scope, release 8.0 and 6.5 in this particular graph, we saw that the defects were 2/3 below industry. So where industry was seeing, say, for every 100 defects, they were seeing 34. So as a QA professional, think about that. You could be either dealing with 3 times the amount of bugs through the pipe, or 1/3. And in the case of working in this environment, they actually had QA professionals working with development teams in testing and defining tests in test-driven development. So that's another thing that we implemented on the submarine program. I actually wrote the tests, or worked with all of our dev teams to write the tests before we wrote the code. So we had a complete layout of exactly operationally what we had to do before we even wrote a single line of code. So think about that, tuck that in your mind about a strategy. If you have test-driven development, or if you don't have test-driven development, you might see different patterns of defects in your code. So this particular company is called Follett Software. They've given me permission to use their name in various presentations and conferences. They're very proud of their software development. And the software, the strategy that they employed goes back over 10 years when I first met them to measure where they were at a fork in the road. Should they keep their development in-house with their in-house development QA teams, or should they outsource their development and keep the QA teams in-house and just do the testing? After looking at their data from their in-house teams, they decided to go the in-house route. Now, I'll say that in terms of what it's done for them in terms of growing the company, at the time that I met with them, they were one of the leaders of, say, the Amazon.com of educational materials for school systems K through 12, as well as higher education universities. They manage bookstores, and they knew their marketplace. And so they felt, let's keep it in-house because nobody knows the marketplace as much as we do, and we're a 1.8, 2.0 billion company. Well, today with their new CEO, Ray Griffith, they just announced that they are about a 3.6 billion company, almost double in size, after a recent acquisition strategy where, in staying with their development and QA strategies in-house, they acquired their competitors. So they've been on a buying spree. This headline just last year said Follett bulks up with the biggest deal ever, and now Ray Griffith, their CEO, is saying, and now it's time to execute. We've gotten all the pieces that we want, and we're now going to continue to grow in our marketplace. At the time when we first did some benchmark analysis of their defect and their QA stats, as well as their schedule and their cost stats, I was asked to do a straightforward benchmark analysis using the QSM approach to compare how they were doing against industry and how offshore developers were doing against industry. And the quick story on this is the one slide that was delivered to the CEO, CFO, CIO that showed the industry average schedule, cost to schedule, defects in their QA phase, and their typical headcount staff in one column. And when we calculated and looked at a half a dozen projects for their environment, they were building not at 3.5 million costs for their release, but 2.2 million, a full 1.3 million cheaper. 7.8 months instead of 12.6, half the defects, 121 versus 242, while using the same typical headcount team size of 35. So the key here was that their QA strategy was showing twice the quality of what we were seeing in industry. And what it does is it turns the whole dynamic of software laws of physics on its head. Most people think we're going to aim for schedule, build it as fast as we can, and then test out the bugs. Their approach was, let's use a QA strategy that includes defining the tests up front as much as we can, using pairing, co-locating our teams, and we'll build clean code in the first place, and from that we get schedule. So I'm going to put out that because they only had half the bugs in their code, that's why they were almost 5 months faster and about 1.3 million cheaper. When we compared that to how not to do it, where you ramp up with a large staff, we see the opposite. We see when you ramp up with a large staff, as I explained before, you wind up having 3, 4, 5 times the defects in the code, and then you miss your date. So now what they're also doing is they're creating value and profit will flow. That's how they got to be a $3.6 billion company. If you're interested in reading about some case studies on this, Mike Cohen, in one of his bestseller books, Succeeding with Agile, published the results of my research in chapter 2, I believe. So take a look. So that's about what sets the stage for low or high defects. We'll take more questions about that as we get towards the latter part of the webinar. But let's talk a little bit now about predicting the future. So knowing what we know about our past, and if there's a saying that says the past is prologue, how would we use that information to come up with the best strategy or give input to our management team about proper planning? I'll use a flight planning analogy, like when I file a flight plan using guidelines from the FAA, how would I ideally lay out a plan that's going to set me up for a lower defect curve? And what we try to do is we look at our constraints. So if you're in the middle of a project or you're about to be on a QA team that's planning its project, be watchful, be observant. If they have a scenario where you've got dislocated teams, not in one place, you've got levels of experience that are not optimal, you've got people spread out, and you've got a large team ramping up, like in that lower corner there, the management constraints. The defect curve that you see on the right is something you may have to be prepared for. And I believe in early warning. Like if I know something's about to hit me, I want to know in advance. And so when I was the QA lead on the Triad navigation program, I looked at how we were implementing our strategy, and then I wanted to understand what could be coming down the pike so that we could plan out our sequencing of the tests, we could plan out our test cases, we could be staffed at the right level for test professionals and run tests in an optimum way that could be the right combination of parallel versus sequential so that we could execute our tests. I wanted to have as much automated testing as possible, because if we relied on manual tests in our world, that would have been very expensive, because to do manual tests we had to do it at sea on a ship that deployed out of Cape Canaveral, Florida, and then ran tests in a very, which was very expensive on a Navy ship in order to find and fix our defects. So to the greatest extent we could use automated testing, automated unit testing. We wanted to be able to lower the curve as much as possible so that when we got to manual testing, we weren't going to be overwhelmed. So that's something to think about as you plan your test strategy and you start to think about detecting defects. We'll talk a little bit about capturing defects in real time, either during a sprint or on a waterfall project, and creating a chart. What's your curve look like? Does it look like it's descending on a downslope on the lower right? Or is it staying level? Or is it climbing? So that's something that you'll want to do. This is the sequence of release estimation planning. If you're so inclined to be able to be a participant in the planning, know what planning strategies work poorly and from a QA standpoint, and know what works well. So I want to talk about, like, once we're in flight and we're in the middle of a release, there's an idea of saying, what if somebody were watching over you, like someone over me while I'm flying my plane in the mountains of western Massachusetts at sunset? This is the idea that you can have the FAA catch you on their radar screens and just help watch out for other traffic and what your direction is. So I'll use this analogy about having something called radar flight following, so that you could see from a QA vantage point what things are looking like on your scope. And so consider the idea that your release is, metaphorically speaking, a flight originating at its point of departure and needing to fly through weather in the yellow and red on a safe course to get to its ultimate destination, what kind of things from a QA standpoint would be useful in terms of watching you on the defect screen and watching that defect curve? So you want to be able to capture bugs in real time, perhaps over the course of a calendar timeline. And in this case, it's, say, in the blue dots, you'll see that there's a initial low level of bugs, and then there's a spike. In this particular client, the spike reached a peak, and then it started coming down, came way down. And if I were to ask a question and someone might venture an answer to say, why do you think we see a zig and a zag during testing? You're surmising of, well, maybe we have a surge of running test cases, and then while we're actually waiting for a next drop and then release, there's a pause. And during that pause, maybe the bugs are not being detected, and then maybe we'll have another spike when we begin our next test cycle. And if you were watching this client where we were doing in-flight following, your answer would be right. So not only did we plot the defects week to week or month to month, depending on your frequency, I'd suggest at least weekly, or if not bi-weekly, you'll see a pattern. Now, there are mathematical models now that can then overlay a curve fit, which is what you see in the red and then the green and the yellow. And that curve fit superimposes a Rayleigh curve and does a calculation of what curve is it following. Now, this happens to be the total defects found, including all severity categories. So everything from severity 1, severity 2, severity 3. It could be critical, moderate, cosmetic. We tend to see that good QA teams capture at least 3 levels of defect severity and then plot them. So you could plot them in terms of total defects. You could plot them in terms of severity levels by category, which is what we do in our models, something called the Software Lifecycle Management Model, or SLIM, and then look at the proportion of the ratio of how many are critical, how many are moderate, how many are cosmetic or minor. A heads up could be, if you're a QA test lead and you see far fewer severity 1s, very minimal number of critical defects, and that most of them are cosmetic, well, that's great. On the other hand, it could be a really difficult thing if a large percentage of your defects are critical or severe and only a few are moderate and cosmetic. So we would advise that you at least keep some form of defect tracking for detection. Keep them in some kind of QA log, which a lot of organizations now have. But if you really want to go into another level of seeing, have we hit our peak and are we starting to see that tail, consider the possibility of models like this that would be able to overlay and superimpose what a Rayleigh curve might be fitting to your data. Now, the thing about predictive aspects of radar flight following or GPS navigation in your car is, if you know your position every step of the way, say as you're driving down the highway and you're looking at the GPS in your phone or your Garmin, it not only looks and says whether you're on your course or you've gone off the wrong road, made a wrong turn, but it will also give you an estimated time of arrival. And the estimated time of arrival is really reading ahead based on the curve that you're showing and looking at the point where your curve is way down low, at the point where, say, 95 or 90% of your bugs have been found and fixed. And that's your schedule. That's really when you're going to be able to deliver. So one of the value adds that we now help QA organizations achieve to present to their senior leadership is defect analysis that will forecast the schedule based on the defect curve. This is a groundbreaking mathematical technique that we discovered over 2 decades ago. And this is where we find that we could really help senior leadership know what the ETA is based on the bug curves. And from that, we get more stakeholder support for our QA efforts. We actually expand the footprint of the value proposition of our QA team, because oftentimes, like Rodney Dangerfield, we don't get no respect, right? This is a way that we have been helping teams get more respect. So think about looking at your defect curves in terms of detection, but use that information by detection and category to maybe help with forecasting and prediction. So what can we summarize as we wrap towards the conclusion here and get to perhaps take some of your questions, which you may want to start thinking about, because we're about, I want to be about 5-10 minutes away from questions. What do we know? What's the secret sauce from a standpoint of preventing, detecting, and testing defects? Well, first on the front end, we find that experience is critical. If we call software knowledge work, it's really about taking knowledge of what's in the gray matter between our ears on team and migrating it into a domain called software and emulating human thought, emulating problem solving, emulating decision making in a machine that is amongst human brains. And so if you have the smartest people you can get, you're going to have the most clean code and code that really does what you want to do. You may want to really consider whether you go with a mix of inexperienced people versus experienced. How would you mitigate inexperience? Maybe you'll do pairing, because inexperience costs money and drives up bugs. That's no secret. The other lesson learned on secret sauce is short feedback loops. And so from a standpoint of preventing defects, if you have the shortest possible distance between 2 points on your development QA and your business analyst or end user, you're going to have the fastest communication possible and accelerated learning and execution. We find that as much as remote working and working in terms of telecommuting seems convenient, there are some days that nothing works better than face-to-face. So where possible, the ideal might be face-to-face. And if you can't be face-to-face, find a way of shortening that distance between 2 points as much as possible and having instantaneous feedback loops. A tired mind is an unproductive mind and a mind that makes mistakes. As a pilot, we actually have something called an I am safe checklist. And one of the criteria for no fly is exhaustion. And so if there's a chance of making a mistake in the cockpit, you have a much higher chance of doing that if you're tired and you're burned out, because a tired and burned out mind is not creative and is not reflexive or responsive. So one of the things about being as productive as we can from a QA standpoint, or even a total development team, is a sustainable pace. And that's one of the tenets that Kent Beck wrote about in Extreme Programming. Let's try to keep a sustainable pace. If you're finding that your pace is not sustainable, you really need to find a way of remedying that and working with your management teams and map it into directly how it results in a certain delta in your bug counts. You can actually monetize exactly how much a bug is costing you. And if you have 3 or 4 times the bug in the block of code, managers really understand that what that means, it can be translated to money. Transparency. In terms of detecting defects, one of the things that we do with people and teams is we have them publish it. It could even be that these charts are pushed to the web or pushed to a shared drive where people can pull things onto their mobile device, and that they can be able to get the latest defect statistics on their handheld device. Transparency is a great floodlight, said Ken Schwaber. People who thrive in political maneuvering hate Scrum. That's an interesting quote. High bandwidth communication. Best teams have wide open pipes. This kind of is connected to the idea of short feedback loops. But if we're looking at moving information among our team about defects and defect remediation, if you can have that accelerate among the communication paths of the team and have rapid information flow, we find that that's also what drives the slope of that Rayleigh defect curve down in an accelerated fashion. So as we fix our bugs faster and we thereby reduce and shorten our time to delivery, that's going to be a good thing that comes out of high bandwidth communication and transparency. The last thing is a little whimsical. Build a little less. If you look at this child's puzzle, which used to be a favorite of my kids, it's called a 15 puzzle. It's got 16 slots or spaces on a grid 4 by 4, and the idea is to get them in sequence 1, 2, 3, 4 across the top, all in white. 5, 6, 7, 8 in the middle. And if you ask yourself the question, what's the secret to solving this puzzle or to being able to solve the puzzle? You'll probably have the logical answer, there's an open square. There's an open square that allows us to move the tiles in different places and to be able to shuffle them. Software teams today often don't have an open square and they're stuck. In other words, their backlog of what they've committed to building is already beyond the capacity of what the team can deliver, and now they're trying to figure out where they can take things out. Or they wind up underestimating the story point complexity of a group of stories in the backlog, and then when it starts blowing up, they find themselves constrained in not being able to move, and it effectively fills the square. I'm going to say an adage that says quality is inversely related to quantity. And the problem among our development teams is we often take on too much in the backlog and then drive our defect rates up. I think QA professionals have a voice that can say, if you want to reduce our project risk, and you want us to be able to have a lower defect curve, listen to us about keeping an open space. Give some contingency. Allow the team some room to move. Don't be tempted to fill in every little blank square. And so maybe hold that as an idea that you can communicate to your management teams. And then finally, know thyself. Are you above the industry average on your defect density? Are you on the average? Are you below? Do you tend to build systems in a faster schedule with larger teams, so do you tend to use smaller teams? You know, one of the things that you could do is collect some of your own metrics and answer the questions, you know, how do we stack up? Like, how might we compare in terms of our defect patterns on what we're detecting against our peer group in, say, an industry sector for, say, financial services or medical devices or mobile devices. So one of the things that we've done in our research in QSM is publish trends. We can look at time to market trends by industry sector, effort trends, staffing trends, and bugs during QA. And I'll share with you that these insights that we've gathered on an industry level came from working with clients where we helped them build their own measurement frameworks on looking at defect patterns. So in the lower right on bugs during QA, are you below the line, are you on the line, or above the line? And I'll share that one thing that we thought of as we were preparing for this webinar is, hey, what can we do that could be a bonus for people who want to pursue this topic a little further after maybe having some ideas stimulated from this webinar? What about offering an opportunity to do a confidential, quick look sampling of, say, what's your defect density? So across releases, small, medium, or large, would you want to pick one of your more recent releases and some of the bug counts that you see in your code and have a private feedback viewing of your project, which you can even keep anonymous, and it's just between us. So that's something that IIST and I have discussed leading up to this webinar. We haven't made a decision on it, but we want to put it out to you, put it out to the group, and you can kind of let us know through feedback in your response or an email. Say, yeah, I'd like to do this. Would you be able to make it available to us? So let us know. And with that, we're reaching the conclusion with plenty of time for open QA. Again, I'm Michael Ma. I'm the managing partner of our New England, Massachusetts-based QSM office, QSM Associates. I've given this talk along with one of our Swiss partners in Zurich, Switzerland, where we've done benchmark study in Germany. So you can see Andrea Jelly over there. I don't know if we have folks in Europe, but if you're dialing in from Europe, we do have offices in the Netherlands and also in Switzerland as well as the United States. And so that concludes our webinar. Eric, I'm going to leave it open for questions now, which we can take.
Perfect. Perfect, Michael. Yeah,
and have a little open dialogue.
While we're waiting for some questions to be submitted, maybe just one or two typical questions that you get while giving this presentation in the past. Do you have any questions like that?
Yeah, sure. You know, one of the most common questions I get is something I alluded to about when QA professionals actually track defects. They ask about severity levels and double counting and redundant defects. I tell them that they should at least try for 3 and look at the patterns, set up pie charts, publish those pie charts, make them as transparent as they can be, because if we really want to shorten our cycle time about remediating defects, we can even create a chart that shows the rate at which defects are opened and then rate at which they're closed. You'll see 2 different lines that kind of either follow in step, or defects closed might be lagging defects open. And then we also create a chart that shows defects closed minus, or defects found minus defects closed, and then divided by total number of defects found to date. And then when you look at that, that's your technical debt. That's your remaining defects out of total. And if you start seeing that climb into a yellow or a red zone where it exceeds 10% of total defects found, or the opens exceed 15% of total defects found, it's like a statistical control bound trigger that will give you an early warning to try to catch up, because if you get closer to the delivery date and you're still in the red zone, that's going to be technical debt that you're going to be stuck with paying down while you're working on the next release. So that's a quick metrics trick that we often get for questions about defect detection, and then making sure we create the fastest possible curve going down on that defect Rayleigh curve.
Great, great. Looks like we do have a few questions submitted there for you.
Okay, so one of the questions here, let me see if I can expand it out a little bit, says, there's quite a bunch. There's a big list. I'm trying to figure out a way of expanding this. Eric, can you see the same question list on the panel there?
Sure. Let me just go ahead. One of the questions was just a little bit of clarification. It said this: the reduction in defects, was that the effect of the pairing in programming? Is that correct?
Yeah. One of the things that my good friend Tim Lister, who've written books like Peopleware or Waltzing with Bears, Managing Software Risk on Projects, he talks about pairing, and when he was giving a talk while I gave the keynote that featured this Follett case study, he said, what are we doing when we basically have a pair? We have an instant code review. And that is true. So what happens is the defects don't wind up in the code preventably in the first place. So the mistake doesn't get made, which then has to be found and fixed and removed later on. And so the way I think about it, too, as a private pilot, is that if I'm, say, flying at night, across from Boston to Western Massachusetts at 4,500 feet, if I have a co-pilot working the radios with me and working on communicating with the FAA, air traffic control at Bradley Hartford Airport, there's two sets of eyes. So oftentimes what we'll do is, like, the pilot in command will say, I've got the plane, and then your co-pilot or first officer is also monitoring everything. And if you make a mistake, like you make a mistake announcing your position on a radio, or you make a mistake dialing in a frequency on the transmission for the radio, the co-pilot who's watching catches it. And, I've had this happen a lot and say, oh, by the way, we should be on 22.7, not 22.8. I'm like, oh, I missed that. And then when you get tired, which inevitably happens, we might say, okay, you've got the plane, your aircraft. And then the person in the right seat will say, I've got the plane. And then the person who was formerly pilot in command is watching the other pilot. And that's what happens when you're doing pairing. And it immediately, instantly eliminates mistakes at the root. So that's what we saw when it was possible. And it's not always possible to do pairing. So a lot of people say, well, we can't do pairing. It doesn't kind of work with our culture, or we have such small teams, it's difficult to create a productive pair. That may be true. So you may or may not be able to do that.
Okay. Next question. Can you also talk about whether it's true that most professional software testers are not programmers? Says that she's seeing more and more job postings when she sees that these days that are assuming that testers must be programmers too.
Well, I certainly wasn't, but I knew that the reason for that was because there are a lot of people who could write code far better than I can. And so I was the systems integration group leader. And interestingly, when I was working as a QA lead on the nuclear submarine program, I was not the best guy for doing UNIVAC assembler coding, real-time coding. So a lot of the people that were working in our QA team were not necessarily programmers, but we were very closely tied to, say, the operating procedures that the captain of the ship and the sailors who were in the navigation control console seats how they had to operate it. So we were more from a standpoint of the operators. And I think even today on Agile teams, you'll see that QA professionals who really understand the business really well and will execute a test that covers all the stories that might be in the story backlog, that's your task. And I also think that having really good communication skills, problem-solving skills, and collaboration skills on a QA team are more important than being a good coder.
All right. Our next question is, do you think defects can be found prior to coding through requirements or design reviews? Would you call them defects or something else?
Yeah, anytime that you have the system not doing what it's supposed to do, you can have it during a coding review or during a iteration planning meeting, just to make sure that in this very human communication intensive thing that we call knowledge work, which is software, there's certainly a lot of work that goes on in creating straightforward collaboration and mutual understandings before code is written. So I think that when we're looking at stories, for example, if we're in an Agile environment, a lot of times people will say, some planning poker. We'll look at the story backlog and we'll say, hey, if we were to rate the story complexity in points, story point complexity on these stories, oftentimes hashing the stories out in planning poker where someone says, well, that's so simple, that's like a 1 or a 2. And someone says, no, that's not. I've got that in my mind as a 6 or a 7. And then when that planning poker exercise is where people show their cards shows a divergence, the hashing out of the understanding of that story even before a line of code is written can be really vital to making clean code. So yeah, I firmly believe that if you have opportunities to catch things early and catch them fast, that's going to be the ideal.
Wonderful. Well, that is all the questions that we have today. So thank you, Michael, for your time today. And I want to thank everyone for joining us for today's free webinar sponsored by IIST, the leaders in education-based certifications and training. For more information on how IIST can help you or your organization, please visit testinginstitute.com. Again, be sure to join us for the next webinar in the series, Gaining Control of Product Releases with Integrated ALM by Dr. Meg DeHanna on November 17th from 11 a.m. to 12 p.m. Central Standard Time. To learn more about this and other webinars in the series, go to testinginstitute.com. You can follow IIST on Facebook, Twitter, LinkedIn, and YouTube to find out more information about IIST news, events, and promotions. Thank you all again for joining us today. Michael, any last comments?
I want to thank everyone. We had a great audience, a really great sign up. A whole lot of people came to hear this. It's my privilege and pleasure. Don't forget to let us know if you'd like us to offer that complimentary private assessment of your defect profiles. If you want to try to get some copies or some sampling of that, I can send copies of the data collection guidelines and a very short deck. So if you'd like to vote, cast your vote, say yes, we'd like to have an opportunity to do this as a bonus, let me or let Eric know.
Wonderful. Thank you, Michael.
Okay, thank you, everyone.